topic for Lesson 8.7 is coordinate proof with quadrilaterals. You'll learn to position and label quadrilaterals for use in coordinate proofs and prove theorems using coordinate proofs. How can you use a coordinate plane to prove theorems about quadrilaterals? In Chapter 4, you learned that variable coordinates can be assigned to the vertices of triangles. Then the distance and midpoint formulas and coordinate proofs were used to prove theorems. The same is true for quadrilaterals. The first step to using a coordinate proof is to place the figure on the coordinate plane. The placement of the figure can simplify the steps of the proof. Position and label a rectangle with sides A and B units long on the coordinate plane. And just like in Chapter 4, it's a good idea to use the origin to our advantage. And in this case, since we want to make a rectangle, that'll give us a nice right angle. Now, generally, you don't want to give it more properties than necessary. So because they said a rectangle, not necessarily a square, they gave the sides different lengths. So they just picked A, B, C, D, why not? And they let one side have a length of A, and the other side have a length of B. And then, so this ordered pair is going to be AB. Is there any specific reason they chose those letters? Nope. Is this the only diagram that could be drawn? Nope. This is a sample answer. Name the missing coordinates for the isosceles trapezoid. Okay, and you can't do a whole proof very well on the test, so this is the type of question you'll have to fill in on the test. Obviously, the y-coordinate is C. It's C units up. If this was A, we had to subtract the same thing that we would have to add here, so this would need to be B, because these segments would have to be the same. Place a rhombus on the coordinate plane, label the midpoints of the sides M, N, P, Q. Write a coordinate proof that prove that M, N, P, Q is a rectangle. And the first step they did for us was to position a rhombus on the coordinate plane so that the origin is the midpoint of the diagonals, and the diagonals are on the axes as shown. We labeled the vertices to make the computations as easy as possible. So to find the midpoints, we average the x part of our coordinates, so negative 2a plus 0 divided by 2, and average the y part, so 0 plus negative 2b divided by 2. And we get to continue finding the midpoints all the way around. So if we do n, average the x's, so 0 plus negative 2a divided by 2 is negative a, and average the y's, 2b plus 0 divided by 2 is b. And we follow the same process for p and q. We're trying to prove that MNPQ is a rectangle, so a rectangle has sides that opposite sides are parallel and consecutive sides are perpendicular. So to know about that, we want to get their slopes. So we started with, well, the vertical lines, and anything divided by 0 is undefined, and we would expect that because they look like vertical lines, so their slope should be undefined. And our other two sides appear to be horizontal, and sure enough, when we do the calculations, negative b minus negative b is 0. 0 divided by anything is 0. So perpendicular to an undefined line is 0. And this comes out the same. So a segment with slope of 0 is perpendicular to a segment with undefined slope. Therefore, consecutive sides of this quadrilateral are perpendicular. Since consecutive sides are perpendicular, MNPQ is, by definition, a rectangle. We're at a coordinate proof to prove that the supports of a platform lift are parallel. Parallel lines have the same slopes, so we should probably find the slopes. The slope of AB, we're going to do change in y, so 5 minus 0 over change in x, 10 minus 5, and we get 5 over 5. CD, same thing, change in y over change in x. This time I have negative 5 divided by negative 5, which is also 1. Since segment AB and segment CD have the same slope, they are parallel. Okay, the big idea they have for proof with quadrilaterals is to position a quadrilateral so that a vertex is at the origin and at least one side lies on an axis.